Hello, my name is Wafik, and today I'm going to present about my project, which is titled Malaysian Sign Language Translator Application Using Deep Learning. So these are the table of contents of sections that I will cover for this presentation, starting with the introduction, then system features and demonstration, moving on to deep learning, tools and applications used, and the strengths and limitations of the system, and finally, conclusion for this presentation and project. So for my introduction, I'm going to briefly talk about my project proposal by talking about the problem statement, project objective, and the target audience. So for my problem statement, in 2020, there were around 40,000 deaf people in Malaysia, but there are only 95 sign language interpreters registered under the Malaysian Federation of Deaf. This means that the number of people who understands the sign language is small in Malaysia. Secondly, sign language is not widely used in Malaysia, so this can cause the deaf and mute people to feel isolated from society due to difficulty when communicating. This can be due to people in Malaysia not seeing the need to study MSL due to having little interaction with deaf or mute people in their lives. Thirdly, people could have no time or money to spend on sign language classes. Other than that, relying on books or the internet for translating MSL in real time can be unreliable, as it would be impractical to carry around the book all the time, and translating the words in real time can be time consuming. Another problem is that the lack of practical mobile learning application that encourages and promotes learning MSL. So this project aims to tackle those problems by creating an Malaysian Sign Language mobile application that offers sign language learning and translation to text to bridge the gap between the deaf-mute communities with the hearing individuals, so that it makes the deaf and mute communities feel less socially isolated. So the objectives that were set for this project were to identify current technologies used in sign language conversions. Secondly is to develop a mobile application that can help and recognize and facilitate in learning MSL and deploy it to the App Store. And thirdly is to evaluate the usability testing of the developed application that will be conducted with the end users. The target audience for this project would be anyone interested to learn or trying to communicate with deaf and mute people using the Malaysian Sign Language. So the next section will talk about the features of the developed system while also demonstrating the finished application. Sample features of the interface will be shown in this section. So the first main feature is the dictionary page, where the users can view and learn the signs available here, with the app consisting of a vocabulary of 37 static one-handed signs to learn, including the alphabets, except letters J and Z, numbers from 0 to 9, and a few words such as you, your, and I love you. Users can also search for signs in the dictionary page, where the app will search if the sign name contains what the user has typed in the search bar, such as what is shown in the image here. Another feature is that when tapping on the sign in dictionary page, the user will navigate to another page to view the sign closer. In addition, users can mark the signs on the dictionary page by giving a star to mark it as favorite or bookmarking it. Users can favorite multiple signs but can only bookmark one sign, so bookmarking a sign will remove any other existing bookmarks. This marking feature allows the user to see the favorites list or straight away view the bookmark signs. The second main feature is the translate page, where the user can translate sign language into text in real time using the iPhone's camera that is made possible with the help of deep learning. After that, another feature that was implemented is that upon translating the images, the time label of the sign detected will be stored and can be viewed in the summary page, where the list here will reset once the user exits the summary or translate page. So for the other features, the proposed system was developed specifically for iPhones, but it can be used in iPads and Apple Silicon Macs as well. And finally, both the front and rear facing camera can be used by tapping on the switch camera button in translate page. So for demonstrating the application, I will show an example of it in this slide. So when opening the app, I can see all the signs available for the users to learn. Then I can mark the sign as favorites, and I can view the favorites list in a separate page. And then I can, since this sign was bookmarked, I can tap on the return to bookmark button to view the bookmark signs closer, and I can tap on any sign to inspect the sign closer, and I can use the search bar to search a specific sign. So another main feature was to be able to translate sign language into text in real time. So I can present in front of my camera just like this, and then this, and this, and those are some of the main examples. And when I click on the summary page, it will show the image and the label of the sign, as well as the time of when the sign was detected. At the same time, the front and rear facing camera can be used as shown here. So, with the system features covered, let's talk about how deep learning was implemented into the app, and how the classification model was trained, and how it allowed the sign language detection to be possible. Before that, let's talk about deep learning briefly. So, deep learning is part of a broader family of machine learning method, which focuses on algorithms that are based on artificial neural networks with representation learning. The three main frameworks and application that made the deep learning integration and sign language detection possible in this project were mainly from the Vision, CoreML, and CreateML framework. So here is an overview of the integrating deep learning for this project. What this means after I explain about these modules will be more clear. But for an overview, the data is first collected and is imported into the CreateML, and then the custom classification model is created into a CoreML model. Next, the CoreML is imported into the coding of the application, where the custom created CoreML file can be imported and integrated into the application. After that, the app can now be processed, and the model can allow the sign language detection by using the Vision framework and tools. So, to explain more about what was talked about before, CoreML is a framework introduced by Apple that is made to integrate machine learning models into applications. It uses advanced deep neural networks designed to understand images, video, sound, and other media. It builds on top of Accelerate, basic neural network subroutines, and metal performance shaders. And BNNs is a collection of functions used to construct neural networks for training and inference. A lot of machine learning models can be converted into CoreML format that uses different machine learning techniques by converting it using Python. As seen in the overview before, CreateML is an application that enables building custom CoreML models without coding, and users will only need training data as the application comes with model and templates available, as seen in the first figure here. For this project, the hand pose classification template is used, and the images would need to be imported. By importing the images, the model can be trained, and the training process of the model can be considered as high as seen in the second image here. In this case, 250 images were collected for each science. And an advantage of CreateML is that images of any size can be used for training, unlike other machine learning models. The third image shows the preview tab, which allows developers to input sample data and test the model. The wireframes of the hand landmarks will also be shown. After training the model, it can now be imported into Core ML format and is now ready to integrate into the proposed application. Vision is the last step that the project needs in order to apply deep learning into the application. It is a framework that is used to apply image analysis and computer vision algorithms to images and video. It can detect text, face landmarks detection, recognize barcodes, and general feature tracking. The vision hand pose detection algorithm allows detection of hand landmarks by applying deep learning algorithms, as shown in this picture here. And the detection of hand landmarks are made by creating a request handler and a request into the coding of the app. After obtaining the hand observations, the application can pass the requests of the hand observation results to the custom Core ML model created in CreateML previously to perform the analysis and detect the sign language performed. This snippet shows is the coding for the hand analysis and translation in the translate page of the application to be made possible, where the deep learning technique are applied in the system. To briefly explain, each frame captured from the camera will be applied with a vision request, and the hand's location and landmarks, the coding for the vision hand detection, and the request from the image is applied here, and the captured data will be sent to the custom classification model and will return the top estimated hand pose label detected with its confidence score. The translated label will be changed to the sign presented on the camera only when the label is predicted with a high confidence of level. So in this coding, it will display the sign if the confidence is greater than 85%. With that in mind, let's talk about the other tools and applications that I have used throughout this project that help develop the proposed application possible. For the data extraction, Adobe Premiere Pro was used to extract data of hand poses that will be used for training the machine learning model described previously in CreateML, where the recorded video of the sign will be converted into sequence of images and will be saved into a folder for every sign as shown in this example here. Secondly, Balsamiq wireframes was used to wireframe the proposed system by planning and placing elements of the user interface. After that, Adobe XD was used for creating the application logo and for creating and designing the prototype of the application after creating the wireframe in Balsamiq to see how the application will look like as shown in the figure here. The fourth tool is Xcode, which is the main IDE created by Apple that allows for developing, testing, and distributing apps for Apple platforms. The application was coded in Swift programming language, which is the primary programming language used in Xcode. Besides that, other benefits of Xcode includes that it has a source code checker that will highlight any errors and suggestions on how to fix them, as well as an autocomplete feature which will result in rewriting the source code more manageable. The user interface can be designed here as shown in this image, and the right image shows the process of uploading the app to the App Store Connect for deploying the application to the Apple App Store. Next is Adobe Illustrator, which was used for designing the application's launch screen to make the app more nicer and have a unique background, logo, and title. Another Adobe tool that I use is Adobe Photoshop, which was used to edit the images captured to store all of it into the same shape and format while cropping the background as seen in the image here, so that it is easy to display it in the dictionary page with a consistent design. And finally is the App Store Connect, which is a platform where the apps will be managed, uploaded, and submitted for review before it is available on the App Store. All the information about the app will be created here, such as the screenshot, description, pricing, genre, and more. The app analytics can be viewed here as well. The application build is uploaded from Xcode, and the right screenshot is the finished apps page available on the App Store that anyone with an Apple device can view and search right now. Next, let's talk about the strengths and limitations identified while developing the app. So the system strength includes that it is easy to understand and use due to the clear user interface design. Secondly, is the use of database to store information of signs and the ones that are marked as favorites and bookmarked. Thirdly, the application does not need any internet connection to use, as all of the functions can be used offline. Other than that, the result of the sign language translation is displayed in real time. Besides that, the user can use either the right hand or the left hand to perform the sign language translation. Apart from that, the application is lightweight with around 22 megabytes to download, so it will not take much of the user's device, much space. Moreover, the app has a dark mode feature which will turn most of the elements of the user interface dark. Finally, this application protects the privacy of users' information by not collecting any data from them. So to demonstrate, one of the strengths is that the application can be viewed in light mode or dark mode, as shown in this example video here. Due to time limitations for developing the proposed system, it is certain that limitations of the project will occur. First is that the application has limited vocabulary as it only consists of 37 static signs. Secondly, the translate function can only detect static signs and not dynamic signs. Third limitation is that similar signs can cause the translation, such as the number 4, which is like this, with letter B, number 9 with the letter F, letter T with letter X, and letter A with letter S. This is expected as this can be due to the data captured is only by using the author's hand and not varying the data captured with other hands with different shapes and sizes. Other than that, proper lighting is needed for the translate function to work properly by using it under good lighting conditions with good enough contrast between the camera and the background. Besides that, the app can sometimes detect feet as hands, as it is part of the current hand pose classification model's limitation according to Apple. In addition, hands that are covered by gloves may not be detected. Apart from that, this app is available only for iOS devices and not for other operating systems such as Android. And finally, the summary function can sometimes be buggy by saving random images while the user is not performing any signs in front of the camera. For the final section, I'm going to conclude this project by talking about the future enhancements, project experience, and conclusion. So for the future enhancements, it is certain that the app can be improved by adding more features and improving existing ones that can be added in the future. First is that the vocabulary list of signs can be improved in dictionary page by adding more signs, including dynamic signs. Dynamic signs are signs that require movement, so this feature can be shown in GIF format in the dictionary page. Secondly, the app can have support for more sign translation, so this enhancement can be achieved by using more than one type of classification model, so that the application will know if the user is showing a static or dynamic signs. For dynamic signs, location of hand with head and body will be needed, such as for father, for mother, for thank you, and for I am fine. Thirdly is improving the deep learning model accuracy of the sign translation, and this can be done by adding more hand models from different people with different hand sizes, shapes, and skin tones to improve the performance of the model. And finally, the app could get a native support by porting it to other mobile operating systems, such as for Android devices. So this can be achieved by changing from native app development to cross-platform app development. So in conclusion, a lot of knowledge and experience were gained from the research done throughout the development process. Before the system implementation, literature review and development of the research methodology was carried out to find out similar systems that was implemented before and to know how the proposed application will function. And this project has allowed me to be more exposed in prototyping experience, so I'm personally getting more used to it. Other than that, I'm learning how to code with Swift programming language and learn how to navigate through Xcode, so I can use most of its benefits and features which can be applied in future projects. Besides that, I learned the whole process of deploying apps to the App Store, and this experience can allow me to release more applications easily in the future. And finally, I learned how to implement frameworks and tools provided by Apple to integrate machine learning into applications easily. In conclusion, by reviewing back the project objectives, all the three stated objectives has been covered successfully in this project. Other than that, the app is currently planned to have more updates in the near future to take advantage of the Apple Developer Program that was paid with a membership of 1 year, which was the requirement for deploying the applications to the App Store. And with that, the project is concluded with the title of Malaysian Sign Language Translator Application using deep learning. So that is all from me. Thank you for listening to my presentation, and I would like to take this opportunity to express my full gratitude to Dr. Rajamani for becoming my project supervisor and Dr. Narendrajit for being my class lecturer for throughout my project. So biggest thanks for all the supervising and guiding me throughout the project. And huge appreciation to all my family, friends, and others who helped me along the way. So that is all from me. Thank you and bye-bye.